Hi guys, sorry I'm out today. My little one is sick, so I am going to make you this video on the first day of 6.5. We are back to solving equations again, so at the end of all these problems you should be telling me what x equals. So we're going to be solving what are called radical equations. A radical equation is an equation that has a radical in it, but the important thing is that it has a variable either in the radicand or there's a variable under a rational exponent. So your goal is always to unwrap the problem just like we usually do with equations. So if you look at number 1, we want to unwrap that. We want to get the square root by itself first. That's your first goal, is to unwrap everything away from the square root symbol. So the first thing we want to do here is add 5. Then we would get the square root of 5x plus 1 equals 6. Your next step is to get rid of the square root, since that's the thing that's on the outside of the problem. So to get rid of that square root, I'm going to square both sides. And then I would have these cancel each other out. 5x plus 1 left equal to 36. Subtract 1. 5x equals 35. And divide by 5. X equals 7. Done. Let's try another one. This one's got a little bit more going on. So the first thing is to unwrap the square root. So you have to get rid of whatever's farthest away. So the first thing we want to get rid of is the plus 3. We're going to subtract that first. And it'll be 5 square root x plus 2 equals 10. Again, the square root has to be by itself before you square it. So the next thing we need to get rid of is the 5. So I divide by 5. Get the square root of x plus 2 is equal to 2. And now I need to get rid of the square root since that's on the outside of the problem. I unwrapped everything else. So to get rid of that, I square both sides. Cancels out the radical on the left. I have x plus 2 left. 2 squared is 4. And then I just need to finish solving here. Subtract 2. X is equal to 2. And if you plugged it back in, just to prove to you that it would work, watch what happens if I plug it back in. 2 plus 2 plus 3 equals 13. I get 5 times the square root of 4 plus 3. Square root of 4 is 2. 5 times 2 plus 3, that's 10 plus 3, which is 13. See? It works. Alright, the next type of problem we're looking at is problems that have rational exponents, which is this little guy right here, that 2/3 power. So we need to work on getting the equation unwrapped and making sure we're doing each of the steps in the right order. So the thing that's technically farthest away from x right now is not the 2/3, it's the 2. If you think of your order of operations, that's farther away. So we need to get rid of the 2 first by dividing. Try and keep that 2/3 tiny so it still looks like an exponent. So then we need to talk about what to do to get rid of that exponent, because now that's what's on the outside of the problem. So to get rid of that, we have to, if you think about what we usually do with fractions, we usually use the reciprocal. So we are going to use the reciprocal, but we're going to keep it a teeny tiny 3/2. So when we write it on the other side, it's a teeny tiny 3/2. We're actually using the reciprocal power. So you need to make sure you keep it as a power. So those, when you multiply them, because a power to a power you multiply, cancel each other out. You get x plus 3 is equal to, now your third step here is to rewrite the power as a radical. So this is what we were doing the last 2 days. So really the square root of 9 cubed. And then you have one really, really important step here. You need to think about, for even roots, if the root ends up being even, for instance in this one we took a square root. Whenever we take a square root in a problem, we need a plus or minus sign. So there should be a plus or minus sign there. So now if we simplify that radical, that is really the square root of 9, which is 3, and then 3 cubed is going to be plus or minus. You need that plus or minus sign, plus or minus 27. So then from here, we need to break apart that plus or minus sign. So I'm going to make this x plus 3 equals positive 27, and then x plus 3 equals negative 27, and we have to solve 2 separate equations. There are going to be 2 answers to this. So we subtract, we get x equals 24, and then subtract here, and we get x equals negative 30. And then there is one last step. The last step is to make sure we check for extraneous solutions. What that means is we have to take our answers and plug them back into the original equation to make sure that they work. And where you can do this, really easy place to do this is on your calculator. If you just plug it in, especially any ones that have a rational exponent in it, you can actually plug it in with the equal sign and it'll tell you true or false. I'm going to show you a picture of that right now. If you look here, now I had typed this in the calculator and it told me both that one's true with the 24 and that one with the negative 30 is true, so they're both going to be solutions. Sometimes it might say false, that means it's not a solution, and you would cross it off. Alright, let's try another one. Again, your first step is to try and unwrap the problem. So in this particular problem, the thing that's on the outside is the 4/3, or the 3/4. So to get rid of the 3/4, we're going to take each side to the 4/3 power. Again, that's a teeny tiny 3/4. So keep it a teeny tiny 4/3 when you write it in. So you know that it's still an exponent, that you're not multiplying by 4/3, but you're taking it to the power. The 3/4 and the 4/3 cancel, so you have 2x minus 5 left, equal to, now that's going to mean, let's rewrite that, that's going to mean the cube root of 27 to the 4th power. And then we look at that, that is the cube root. Cube roots do not need plus or minus signs because they're odd. So no plus or minus because it's an odd root. So this goes back to that very first lesson we did this chapter. It's only the even roots that need plus or minus signs. So we get 2x minus 5 is equal to, the cube root of 27 is 3, and then 3 to the 4th power is 81. Just keep solving for x now. Add 5, this one only has one equation. So we get 2x equals 86, divide by 2. X is equal to 43 is the answer. And again, you would check this. I don't have my calculator with me, so I'm just going to check it by hand. That's your other option. Just plug it into the original equation. We're going to get 86 minus 5. That's 81. And then we have to do what it says to do. It's the 4th root of 81 cubed. The 4th root of 81 is, in fact, 3. And then 3 cubed is 27. So we get 27 equals 27. We're good. So it works. Check. Let's try. Now this would be a really good problem if you pause it and you try this on your own, and then you watch through the video to make sure that you did it correctly. So I'm giving you another second to pause it, and then try it on your own. So first step is to unwrap. So your first step to unwrap this one should be minus 5. We get x plus 20 to the 4th power is equal to 16. And then we have to use the reciprocal power. So I'm going to write a 5/4 next to it, and then on the right side I'm going to keep it teeny tiny 5/4. Those cancel each other out. You get x plus 20 left equal to, now this is the 4th root of 16 to the 5th power. Since it's a 4th root, you do need to add a plus or minus sign because that's an even root this time. So we get x plus 20 equals, the 4th root of 16 is 2, and then 2 to the 5th power is 32, so it's going to be plus or minus 32. And then since this has a plus or minus sign, I would encourage you to write two equations, one with the positive 32 and one with the negative 32, and then we're going to solve each of them. So this one, if I subtract 20, I get x equals 12. And then this one, if I subtract 20, I get x equals negative 52. And again, at the end of the problem, you're supposed to be checking to make sure those are in fact solutions. So if I do a quick check, if I plug in the 12, I'm going to get 32 under that radical, or under that rational exponent. So it's going to be 32 to the 4/5 plus 5. And that means the 5th root of 32 to the 4th power plus 5. That's going to be 2 to the 4th power is 16. 16 plus 5 is 21. It worked. And then when I do negative 52 just gives me a negative 32 under the rational exponent. And then I would take the 5th root of negative 32 and then to the 4th power plus 5. Running out of room here. That's going to be negative 2 to the 4th power plus 5. This is why we had to put the plus or minus sign. When I take that to the 4th power, it really becomes positive 16 plus 5, which is 21. Check. So they both work. Alright, we got one more type of problem, and then you guys can work on your homework. This last type of problem is when you have two radicals in a problem. They're actually really, really easy if you remember what to do first. If there's two radicals, the only thing I can do, they're trapped inside the radical, is to get rid of the radical first. So I'm going to square both sides here. When I do that, the radical on the left cancels, I get 2x plus 1 left. The radical on the right cancels, I get 3x minus 7 left. And then this is really, really algebra 1 problem. Get your x's together. Get your numbers together, and you get x equals 8. And if we check that real quick, which you don't have to do for this section, but just to show you that it really does work, if I plug it in, I'm going to get the square root of 17 here, and then I'm going to get 24 minus 7 is also the square root of 17 there. It works. Alright, number 2 is a little different. I have one first step. You can't just jump to the squaring step. You don't want to square it when it has a minus sign in the problem. You want to separate the radicals first. You want them on different sides of the equal sign. So that's what I'm going to do first. I'm going to add the one that's being subtracted. I'm going to add it to the other side. So I can move that one to the other side. Then you can square both sides. Don't square it when it has a plus sign or a minus sign, because technically you'd have to FOIL them together, and I don't think we want to do that. So this radical cancels, we get 5x plus 2, equal to this radical cancels, we get 3x plus 14, subtract 3x, subtract 2, 2x equals 12, and divide by 2, x equals 6. And if you plugged it in, it would work. One more. For this last problem, it looks a little different than the last ones. They have 1/2 exponents. So first thing you still want to do is, just like the last one, we want to separate the parts that are in parentheses. The parts that are in parentheses with rational exponents, we want to separate them. So again, that one that's being subtracted, I'm just going to kick that one to the other side. And then we look at this, and we have to think about what do we do when we have a rational exponent? Well, we use the reciprocal. What's the reciprocal of 1/2? 2. So I'm going to square both sides. When I do that on the left side, it cancels out the 1/2. So I just have the 4x minus 3 left. It also cancels it on the right side. So this is just like the last two problems where everything cancels out. Whoops. And then you just solved. Subtract 2x, add the 3. 2x is equal to 8. Divide by 2. X equals 4. Done. Alright, so try the homework, and we will talk when I get back, hopefully tomorrow.